Astronomy to GCSE, Topic 1.2, our solar system. So 1. What's in our solar system? This point requires a general knowledge of our solar system, so there's no harm having a bit of extra knowledge. Planets. So, to prevent any confusion, I will start at the beginning. What is a planet? Well, the IAU, or the International Astronomical Union, define a planet as a celestial body that is in orbit around the Sun, has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium shape. This is the most complicated, but basically it means that the object is heavy enough for gravity to overcome its original shape and make it nearly round. That's what hydrostatic equilibrium means. The third point is that the planet, or the object, must have cleared the neighbourhood around its orbit. This means that there are not lots of little asteroids and other objects in the proximity of the planet's orbit. And what is a dwarf planet? The IAU define a dwarf planet as a celestial body that is in orbit around the Sun, has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium shape, has not cleared the neighbourhood around its orbit. This means that there can be lots of asteroids or other objects in the proximity of the dwarf planet's orbit. And finally, it is not a satellite. This means that moons cannot be dwarf planets. There are 8 planets in total. In order of distance from the Sun, we have Mercury, Venus, Earth and Mars. These are the 4 terrestrial planets. These are rocky and closest to the Sun. Next we have the 4 gas giants. These are Jupiter, Saturn, Uranus and Neptune. There are currently 5 dwarf planets in total. In order of the distance from the Sun, we have Ceres, which is in the main asteroid belt, which is between Mars and Jupiter. All of the other dwarf planets are in the Kuiper belt. These dwarf planets are Pluto, Haumea, Makemake and Eris. Next, moons, which are better called natural satellites of planets. These are astronomical objects that orbit a more massive object. There are many moons in the solar system. The Earth has only 1, Mars has 2, Jupiter has over 60 and more are still being found. There are over 170 moons of planets known in the solar system. Next, asteroids. These are small irregularly shaped rocks that orbit the Sun. Most of the asteroids in our solar system orbit in the main asteroid belt. This is between Mars and Jupiter. Asteroids are too small to keep hold of any atmosphere, but some larger asteroids have small companion moons, like this one here. This image shows Ida and its companion moon Dactyl. NASA says that if all of the asteroids in the main asteroid belt were to be combined into a ball, that the ball would be much smaller than our own moon. So asteroids are really quite small. Ceres, a dwarf planet, the one that's closest to the Sun, which lies in the main asteroid belt, comprises a third of the mass of the entire asteroid belt. So remember, there are lots of asteroids, but planets and dwarf planets are much larger. Comets. These objects are a bit like dirty snowballs. They comprise of some frozen gases, mainly ice, as well as rock and dust. Comets have extremely eccentric orbits. This means that the orbit is very elliptical, so a comet can be really far away from the Sun or really close. This is the shape of the orbit of Halley's Comet. When the comet is far away from the Sun, it receives less light, so it is colder. When a comet is near the Sun, it receives more light, so it warms up. When the comet warms up, the ice begins to melt. This gives the comet an atmosphere, however only when it's near the Sun. This temporary atmosphere is called a coma. The coma may be hundreds of kilometers in diameter. Centaurs are not the half-man, half-horse that features in Greek mythology. They are called centaurs as they are similar to both asteroids and comets. These mysterious objects orbit between Jupiter and Neptune. They are rocky bodies like asteroids, but like comets, centaurs cross the orbits of the gas giants. Trans-Neptunian objects, or TNOs for short, are objects with an orbit past Neptune. So some examples would be Pluto, Haumea, Makemake and Eris, as these dwarf planets have orbits past that of Neptune. 2. The scale and size of our solar system. If the Sun was on the left-hand side of the screen and Neptune was on the right, then where would all the other planets be? I will use the unit astronomical unit, shortened to AU here. This is the mean distance from the Earth to the Sun. To start with Mercury, this is the closest planet and it's 0.4 astronomical units from the Sun. Next we have Venus, which is 0.7. Then our home planet, Earth, which is exactly 1 astronomical unit from the Sun. Then Mars, the final of the terrestrial planets, is 1.5. They are all very far apart in reality, but compared to the entire solar system, they're relatively close. Next we have the planet Jupiter, which is 5.2 astronomical units away. This is a big jump compared to the last ones. Saturn's then 9.5. Over twice as far away is Uranus at 19. And finally we have Neptune at 30 astronomical units. Now what about the size of each? As we learnt in topic 1.3, the Sun is 1.4 million kilometers in diameter. Where the lines cross on the Sun is the very centre. I had to do this as it just won't fit on a slide. So Mercury is 4,900 kilometers in diameter. If you can't see it on your screen, I do apologise. Mercury is really very small. Next is Venus at 12,000 kilometers, so it's significantly bigger. Then we have Earth, which is slightly bigger at 13,000 kilometers. Mars is then quite a bit smaller at 7,000. Jupiter, which is the largest planet, is 140,000 kilometers, but it's still dwarfed by the Sun. So is Saturn at 120,000 kilometers, which is only a little bit smaller than Jupiter. That's Saturn without its rings on. Next comes Uranus at 51,000 kilometers, and then Neptune is slightly smaller at 50,000 kilometers. What you need to know for the exam is to understand that the scale of the solar system is huge. 3. The astronomical unit. We've already covered this in topic 1.3, so just to refresh you, the astronomical unit is the mean distance between the Earth and the Sun. It is 150 million kilometers. 4. The ecliptic. The ecliptic is the plane that the planet Earth orbits around the Sun. All of the planets orbit in ellipses, a bit like comets, but the planetary orbits are much less eccentric, so they are nearly perfect circles, but just not quite. All of the planets orbit in ellipses and their orbits are slightly inclined to the ecliptic. What this means is that the planets all orbit within a few degrees on the same plane. So when viewed from Earth, all of the planets appear to orbit in the same area of sky. As the orbits are inclined to the ecliptic, the area of sky is a band. This band is called the zodiac. This is a star chart. If you want to download these star charts from the SFA Observatory, then follow the link in the description. The curved line that cuts across the chart is the ecliptic, which I have highlighted in blue. The Sun, when viewed from Earth, appears to follow the ecliptic over the period of a year. Remember, this is not the Sun moving, it is the Earth. But as this is viewed from Earth, the Earth appears stationary and the Sun appears to move across the ecliptic. just like how in a car the hedges appear to be moving and the car stationary. The zodiac is plus or minus 8 degrees from the ecliptic in declination, so up and down. It is in this zodiacal band that all of the planets, moon and sun appear to move. Also, the constellations that are in this zodiacal band are the constellations which the astrological signs are associated. So we have Leo, Cancer, Gemini, etc. 5. Retrograde motion. So what is retrograde motion? I'd recommend that you watch this animation of retrograde motion before continuing. It will help you understand it a little bit. So, in the animation, Mars is moving forwards, and then it suddenly appears to slow down, then it moves back on itself again, before slowing down again, and then returning to move in its original direction. So why does retrograde motion happen? Well, retrograde motion only happens with the superior planets. This means the planets further out than us. The reason why this happens is due to us undertaking these planets. That's why retrograde motion does not occur with the inferior planets, because we never undertake them. This diagram shows how, as the Earth undertakes a superior planet, in this case Mars, the pattern of retrograde motion appears relative to the background of stars. Direct motion is when the planet is moving in its usual direction, represented by the blue arrows, whereas retrograde motion is where a planet appears to go in the opposite direction, represented by a white arrow. As you can see, by drawing lines between Earth and Mars as Earth undertakes Mars as it is going faster, you can see the pattern of retrograde motion forming. 6. Some more astronomical vocab. Okay, so to start with, perihelion. Remember that I said that planets orbit in ellipses around the Sun, a bit like this? Obviously not quite so eccentric. Eccentric basically means extreme, but I have it like this just to show the principle. Perihelion is the point where the planet is closest to the Sun. Aphelion is the point when the planet is furthest from the Sun. Okay, so let's lose the really eccentric orbit and start greatest elongation. At greatest elongation, Mercury and Venus are best viewed from Earth, as they appear furthest from the Sun. Greatest elongation is the point where the angle between the Sun and the planet, as viewed from Earth, is the largest. That's this angle. To be in greatest elongation, the angle between the Earth and the Sun, as viewed from the planet, must be 90 degrees. So that's this one. Mercury and Venus have different values of greatest elongation, as they orbit at different distances from the Sun. The reason greatest elongation is interesting is because if you want to observe Mercury or Venus, these are the best times to do so. Inferior and superior conjunction. So conjunction is where the Sun, Earth and another planet line up in a perfect line. Inferior and superior conjunction can only happen to the inferior planets, so Mercury and Venus. If the Earth is here, then to be in inferior conjunction, the inferior planet will have to be between the Earth and the Sun, so here. To be in superior conjunction, the inferior planet has to be on the other side of the orbit, so it goes Earth, Sun, planet, which means the inferior planet, will be here. So with inferior conjunction, we have Earth, planet, Sun. With superior conjunction, we have Earth, Sun, planet. Similar to inferior and superior conjunction, conjunction and opposition are to do with the Earth, Sun and a planet going in a straight line. But conjunction and opposition are for the superior planets, so Mars, Jupiter, Saturn, Uranus and Neptune. So let's add the orbit of a superior planet. I will also get rid of the orbit of an inferior planet to prevent any confusion. Opposition is where we have a planet, then Earth, then the Sun, all in a line. So like how Mars is at the moment. And conjunction is when we have Earth, Sun, planet. So Mars is on the other side of the orbit. These are a bit more difficult to learn. The important thing is to not get conjunction and opposition confused with inferior and superior conjunction. You have to remember that conjunction and opposition are for the superior planets only. Transit and occultation. Transit is when one astronomical object passes in front of another as seen from a given vantage point. For example, this strange inexistent green planet transits the Sun. This planet would appear to pass across the face of the Sun from Earth. Occultation is a bit different. It is where one astronomical object is hidden behind another. So let's use our green planet as an example. If it were a bit closer to Earth, then when it passed between the Earth and the Sun would not be visible behind the mysterious green planet. You may have noticed that this is inferior conjunction. Well done if you did. So this would be occultation, as the Sun would be hidden behind the green planet. In fact, if you remember back to topic 1.4, a solar eclipse looks very like this, and in fact a solar eclipse is an example of an occultation. Another example of an occultation is when an inferior planet is in superior conjunction, so it is hidden behind the Sun. 7. The physical characteristics of the planets. It would help if you did your own research into this. NASA has a brilliant website for this. This is a link to the NASA website on our solar system. It is really excellent. I'd recommend that you have a look at it and do a bit of your own research. For each of the planets you need to know about its surface features, atmosphere, temperature and composition. I would also recommend having a look at its moons as they have appeared in previous exams. So let's get started with Mercury. Mercury is the closest planet to the Sun and the smallest in our solar system. In fact, Mercury is only a little larger than our own moon. This means that with a lower gravitational field strength, Mercury cannot keep hold of its own atmosphere. And without anything to stop impacts, Mercury, like the far side of our moon, is heavily cratered. The side of Mercury that is in daytime is heated by the Sun to hundreds of degrees, about 430 degrees Celsius. The night side loses most of its heat due to a very thin atmosphere, not retaining much of the heat. This means that the temperature drops to around negative 180 degrees C. It is thought that Mercury has a metallic core and a silicate-based mantle. Mercury also has no moons. Mercury's core is very large in relation to the rest of the planet. If you're interested, it may be worth doing some more research into this. Next, Venus. Venus is a little smaller than Earth, at 12,100 kilometers in diameter. This is only 700 kilometers smaller than that of Earth. Venus has a very thick and toxic atmosphere that is so dense that the surface pressure is 90 times greater than that on Earth. The atmosphere composes of sulfuric acid, carbon dioxide and nitrogen. This extremely dense atmosphere acts like a greenhouse and is an example of extreme global warming. Because much of the heat is retained inside the atmosphere of Venus, the surface temperature is 480 degrees C. Venus has a cratered and volcanic landscape. It also has no moons or rings, but interestingly is the only planet in the solar system to spin backwards in relation to the other planets. This spinning backwards is called retrograde rotation. Retrograde just means backwards. Venus is meant to be composed of a metallic core, just like Earth. The composition of the mantle is unknown, but is thought that the crust could be silicon-based. Mars is about half the size of Earth. Mars has polar ice caps, volcanoes, canyons, and weather systems. In fact, the largest mountain in the solar system, Olympus Mons, is located on Mars. Mars has a thin atmosphere made up of carbon dioxide, nitrogen, and argon gas. Liquid water can no longer exist on Mars due to its thin atmosphere. There are signs that liquid water used to exist on Mars, though. The temperature of Mars is -50 degrees C. Mars does have two moons, Phobos and Deimos. These are both thought to be captured asteroids due to their very small size and irregular shape. Mars is also quite close to the main asteroid belt. Mars's core is metallic, and the mantle is likely to contain silicon, oxygen, and iron. Jupiter is the largest of the planets and orbits as the fifth planet out. The rotational period of Jupiter is 10 hours. This is Jupiter's equivalent to a sidereal day. This very short rotational period drives powerful weather systems. An example of this is the Great Red Spot, a giant storm on Jupiter that is larger than Earth. Jupiter, being a gas giant, has no solid surface, unlike the four terrestrial planets. So the boundary between surface and atmosphere is not as simple as with the terrestrial planets. Jupiter is thought to be composed of mainly hydrogen and helium. As the pressures get high enough, Jupiter gets a layer of liquid hydrogen, then liquid metallic hydrogen after that. It is unclear whether Jupiter has a core of solid material due to the very high pressures. If you are wondering what liquid metallic hydrogen is, it's where hydrogen is under so much pressure that it begins to conduct electricity. Some scientists are trying to create liquid metallic hydrogen on Earth, but because of the huge pressures required, it is proving difficult. Jupiter's atmosphere is also made up of mainly hydrogen and helium. Jupiter has over 60 moons. This is currently thought to be the most in the solar system. Like all of the gas giants, Jupiter has a ring system, although it is not as prominent as those of Saturn. Jupiter's surface temperature is -150 degrees C. Jupiter cannot support life as we know it now, but it may be possible that some of its moons can support life in their oceans underneath their crusts. Saturn, the second largest planet in the solar system, and it sits sixth from the Sun. Like Jupiter, Saturn's atmosphere and composition is mainly made up of hydrogen and helium. Saturn has a dense core of rock, ice, and water. This core is surrounded by liquid metallic hydrogen, and that in a layer of liquid hydrogen. Saturn has over 60 moons, and like Jupiter, more are being found. Saturn has the most prominent ring system of all of the planets. These are made up of several rings with gaps in between them. The temperature of Saturn is -150 degrees C. Uranus is the third largest planet in the solar system. It was discovered by William Herschel, a German-born British astronomer. It sits seventh from the Sun. Uranus' atmosphere is mainly hydrogen and helium, with trace amounts of methane. The methane gives Uranus its bluish-green colour. The bulk of Uranus composes of an extended liquid core containing solid water, methane, and ammonia. Uranus has 27 moons, which are named after the characters from the works of Shakespeare and Alexander Pope, like Miranda and Ariel. Uranus has a faint ring system, and its temperature is -224 degrees C, or 49 Kelvin. Interestingly, Uranus rotates on its side, so it spins horizontally. So whereas the Earth's tilt is 23.5 degrees, Uranus is 98. Neptune is the fourth largest planet in the solar system. It was discovered by Leverrier and Gallet. It sits eighth out, meaning that it's the planet farthest from the Sun. Neptune's extensive atmosphere is mainly hydrogen, helium and methane. Again, the methane gives Neptune its bluish-green colour. The bulk of Neptune composes of a solid core and then a layer of water, methane and ammonia. Neptune has 13 confirmed moons, named after ancient Greek sea gods and nymphs. Neptune also has a faint ring system, and its temperature is negative 215 degrees Celsius or 59 Kelvin. As surface features go, Neptune has a great dark spot, similar in appearance to Jupiter's Great Red Spot. This is part of Neptune's complex weather system. 8. Space probes. How astronomers use space probes to investigate other bodies in our solar system. A probe is an unmanned spacecraft which travels through space to collect scientific information and then send the data back to Earth for scientists to study. Not all probes investigate other planets. Some investigate comets, asteroids, moons, and even planet Earth. There are multiple devices that are in these probes which help scientists perform experiments, analyze the other bodies in the solar system, and take photos. A selection of these devices are cameras. Some of these cameras are not in the visible range of light, some infrared or others ultraviolet. Some probes like Genesis have solar wind detectors. And in order for these to transmit data back to Earth, they all have radio telecommunication devices. A few examples of probes that have obtained data from planets are Cassini, which has analysed the Saturn system, Mariner 9, which has done Mars, and Juno for Jupiter. 9. The problems with getting people around the solar system. There are many dangers with transporting people around the solar system. For example, radiation. The Sun emits a huge amount of radiation, and without the magnetic field of Earth to protect them, the astronauts would be bombarded by ionizing radiation. This would give the astronauts a significantly higher risk of getting cancer, and it may give them radiation sickness as well as other health problems related to ionizing radiation. The next big problem is the space adaptation syndrome, also called space sickness. Space adaptation syndrome is caused by change in g-forces, which affect our perception of up and down. An astronaut can become adapted in a few days in space, but if not, then the motion sickness and disorientation are amongst symptoms. Communication problems. Delays in communication caused by the fact that the distances between the astronauts and Earth are so vast mean that there is a huge time lag between sending and receiving messages. Remember that radio waves can only travel at the speed of light, and in space this causes delays of many minutes between messages. Living and working with the same group of people for months on end can cause psychological and emotional problems. These all have to be considered when making a manned expedition out into the depths of our solar system. 10. Origins of the satellite systems of Mars and Neptune. You should already know the origins of our satellite system, the Moon, from topic 1.2, but now you will have to learn those of Mars and Neptune as well. So to start with, Mars. Mars has two natural satellites, or moons. These are called Phobos and Deimos. These asteroids are very small. To get a scale, I will show you Phobos and Deimos next to our own moon, which is one of the largest in the solar system. So there is Phobos, there is Deimos, and here is our moon. So Phobos and Deimos are really small, and that is them being compared to our moon. Mars is even larger. Due to their irregular shape and their density being similar to most asteroids, it has been decided that they are captured asteroids. I have added their actual size so you can see how small they really are. You don't have to remember their actual size. The fact that they are captured asteroids makes sense as Mars is very close to the asteroid belt. If you're unsure about what captured asteroid means, it's quite simple. It's just an asteroid that has been forced into orbit or captured by the gravity of Mars. Now for Neptune, which has 14 moons. Triton is the largest of Neptune's moons and dominates the others by both size and mass. What is interesting about Triton is that it orbits Neptune backwards. Yep, it's retrograde. Because Triton is retrograde, it is thought that it is a captured body. It may have even been classed as a dwarf planet itself if it wasn't a satellite. Neptune has other moons, like Nereid, which is also thought to be a captured Kuiper Belt object. Neso, one of Neptune's satellites, is so far away from Neptune that it takes over 27 Earth years for it to complete just one orbit. 11. Planetary ring systems. All of the gas giants have ring systems. These appear like very thin rings circling the planet and are in fact located above the planet's equators. These ring systems are composed of multiple rings, which are composed of mainly water and ice, and also rock and dust as well. In Saturn's case, there is less rock and dust in its highly reflective rings. The rings are very wide, and they can be 10 or even hundreds of thousands of kilometers wide. They are also very thin, only about a kilometer or so. Some moons orbit planets in their ring systems. That's the end of Astronomy to GCSE Topic 1.2. Thank you very much for listening and watching.